Hey everybody, we got something really cool at Adafruit and I want to show it to you. It's a glove to improve your golf swing, and we didn't know quite how it worked and like what the sensors were inside, and so I asked Lady Ada to help me out.
Hey everybody! Yeah, thanks Becky. Yeah, this is a cool sensor glove that tells you how much you're gripping your golf club, so it'll improve your swing. Too much grip, too little grip. So let's open this up and see how it does that. Okay, so this glove has sensors in each of the fingers, and that's kind of an interesting way of doing it. So let's check out these pressure sensors. So inside is this sort of, it looks like some sort of clear balloon, and the sensor is actually not in here. This is just air, like an air pocket. And there's a little plastic tube that comes down the length of the glove and out to this electronics piece here. You can remove the electronics piece pretty easily. You just snap this open. And what's interesting is you can see there's 4 ports, and these are kind of rubbery. Actually, there's a soft rubber, and it mates with this soft rubber here, so there's an airtight seal. Let's open this up by getting these torque screws off. I'm going to use the very nice torque set that we have in the store. Okay, let's do this thing. So what's interesting is that this is a common technique. There's a piezo that's attached to the body, and this is what makes it beep. So when it beeps at you, this is a little piezo disc, and the contacts are over here, and they're little springs. And so this gives it like something strong to vibrate against, and it kind of makes this act like a sounding board. And you can see there's a hole in here. There's a port for the piezo so the sound can come through. This is the battery that powers it. So it's a CR2016. And now we've got some chips and some sensors, and to check this out in more detail, let's look under the microscope so we can get some really good images. Okay, we've got this on the USB microscope. That'll make it a lot easier to read these part numbers. For example, this is a microchip PIC16F914, so it's a very basic microcontroller for microchip, probably good for low power. It's 8 or 16 bits. It's got enough horsepower to take all the sensor data and drive the little LCD, but it's not like a microcomputer. It's not running Linux. It's very basic. There's some capacitors around it. Over here, there is a 16044 ST. I'm not sure exactly what that is off the top of my head, but it's probably some sort of op amp or conditioner for these sensors. And then over here we have, let's see if we can get that part number, a 172 also from Microchips. These guys really like Microchip. You can see the Microchip logo here, here, and here. And this might be part of the power supply, or also some more conditioning. There's a lot of resistors and capacitors over here. This might also be the piezo driver. And then here's the sensors. So the pads in every finger, there's a little rubber tube that comes out, and it actually connects to this port. And let's see if we can get the part number off of this too. So using the very close view of the microscope, we see it says SMS420C L1L0261. So that's the part number for the sensor. We'll check out what all these components are using a computer and a search engine. We can look up some data sheets. The nice thing about this design is you can have the pads in the fabric in here, and this is very washable, while keeping the electronics separate over here. You know, if this breaks, you can replace it. If this breaks, you can replace it. I like the modular design, very washable as well.
Thanks, Lady Ada. I never knew that golf was such a hotbed of sensor innovation. We hope to do a lot more of these teardowns, so if there's a piece of wearable technology that you're dying to see the insides of, post about it in the comments, and don't forget to subscribe to our channel on YouTube so you never miss a video.